Welcome you all. Today we will be discussing about how buildings impact the environment. So the first question of thought is, have you ever found yourself asking, does buildings really affect the environment? And if yes, how does buildings affect the environment? We'll discuss it for today's session. So the buildings' negative impact on the environment have paved the way for the growth of green buildings or sustainable buildings today. So the buildings are responsible for a huge number of demand of material demand or resource depletion for its construction, and buildings are known to consume a large amount of energy. More than 30 to 40% of energy produced is consumed by buildings around the world, and buildings are responsible for contributing more than 20% of water consumption throughout the world. And everything has led to cause a global climate change. So we are now suffering due to the climate crisis, and moreover the buildings are responsible for increased carbon dioxide emissions throughout the world. We will have a detailed understanding in this session. So the first major raw material used in building construction is cement. So India is the second largest producer of cement in the world, producing more than 210 million tons of cement, which is around 6.3% of the global production. And Indian cement production is set to increase 4 to 7 times by the year 2050 because of the increased demand. But anyway, we have to consider that per capita consumption of cement in India is comparatively lower than developed countries, which is around 200 kg per person. Though this is not an excuse for the growing demand of cement and usage of cement. And we also should understand that the material costs account for roughly 2/3 of the total cost of a typical building. And this is also one of the reasons we have to go for reducing the resource consumption in the building construction. Moreover, cement is also said to cause a huge amount of negative impacts in terms of pollution or some other kind of sustainability impacts to the environment. And the next important category of raw material is sand. So we all know that conventionally since ancient times we have been using river sand, and river sand has been widely used as the fine aggregates, and owing to the current scarcity we have now switched over to use the manufactured sand in the cement mortar as well as in the concrete. And another material which is highly used in building construction is bricks. The bricks are also used as the base material for roads as a reused or demolished bricks. And we know that for the manufacture of bricks, a huge amount of fertile topsoil is being utilized in major parts of the states in India. And because of the recent interventions by the government as well as by the professional organizations, and more importantly certain recommendations by the BIS standards also, we have now increased the usage of fly ash in major raw materials as a replacement. And we know that 12% of total fly ash generated in India is currently used for the production of bricks and tiles. This is an appreciating note, but still we have to understand, owing to the huge demand and usage of raw materials, this percentage is very meager and this percentage has to be increased. And the third important material which is used in large quantity is the aggregates. So aggregates have been in use for the manufacture of concrete and in foundation and so many other applications in the structural built environment. And we have used granite, basalt, etc. as the aggregates in our building construction. And referring to the aggregates, we have a huge demand of more than 2 billion tons of coarse aggregates per year in India. And the recent commitment of the Indian government to build more than 30 kilometers of roads per day adds to the huge demand of aggregates still further. So there is a huge requirement of both fine aggregates and coarse aggregates as well as cement as per the growth of the buildings in India. So we have to check whether all the raw materials are available as per the demand, or else we have to go for a sustainable alternative to search the replacement for the raw materials. And one more important material to be considered here is limestone. Limestone is one of the raw material which is used in the cement manufacture process. So India utilizes about 226 million tons of limestone in cement manufacture as well as in iron and steel, chemical and other industries, out of which the utilization share of the cement industry is more than 93%. So the research reports also denotes that the limestone resources in India will last only for the next 35 to 41 years. So after 40 years or 50 years, we won't be having the material called limestone. So we have to really pay attention to this and search for another good replacement of limestone, especially for cement manufacture. And one more thing to understand is limestone also causes huge amount of negative impacts in terms of pollution or during the process of quarrying. So the replacement of limestone will be a very good alternative to satisfy the future requirements as well. And we have discussed about major amount of materials. One important other sector to be considered is iron and steel industry. Steel has a very high recyclability potential, and also steel has been used extensively in the built environment. But thanks to the Indian economy, with the help of rag pickers or scrap vendors, even minute quantities of steel scrap is recycled back into the industry, and so there is no major problem of iron and steel as a waste in Indian economy. So because of this iron and steel sector denies any other suitable intervention on account of structural and economic reasons. So as of now, iron and steel industry or usage of iron and steel is appreciated or is not under any intervention in the green building scenario. And the next important category to be considered is the construction and demolition waste. India generates around 716 million tons of construction and demolition waste per year, and most of this waste ends up as simple dumped waste in landfills or along the roadsides. This construction and demolition waste has a huge applicability potential as recycled aggregates, and also the construction and demolition industry should also take up steps to use the reused bricks in the major construction activities today, so as to minimize the huge amount of waste which is being simply dumped in the landfills. This will also lead to savings in the usage of raw materials. And there is an interesting fact to understand regarding the emissions. So the research mentions that processing of 1000 kg of natural aggregates like quarrying, crushing and transport processes emits around 20 kg of CO2 into the atmosphere, whereas the same processing of 1000 kg of recycled aggregates, which is produced from construction and demolition waste, has the ability to produce 12 kg of carbon dioxide into the atmosphere. So comparing these two, we understand that the material replacement of 1000 kg of recycled aggregates, which is produced from the construction and demolition waste, will prevent emission of 8 kg of carbon dioxide into the atmosphere. Thus, we understand that simple replacement of recycled aggregates rather than using the natural aggregates can cause savings of around 8 kg of CO2 per 1000 kilogram of aggregates. So this will really cause a huge savings or a huge improvements in the carbon dioxide mitigative measures, and thus if we employ such kind of activities, we can really save around 8 million tons of carbon dioxide per annum compared to the huge usage of materials in Indian scenario. And also the aggregate demand in concrete and road laying in India is estimated to be 1.1 billion tons per annum. So if we are going to replace huge such demand as the recycled aggregates from construction demolition waste, it will cause a huge impact to the minimization of carbon dioxide emissions to the environment. And thus, in adding to this, if M sand is also produced using carbon dioxide and using construction demolition waste instead of natural stone, additional carbon dioxide savings of about 8 kg per 1000 kg of waste can be achieved. And more importantly, such processes, that is using M sand from recycled aggregates, will help in reducing pressure on rivers for extraction of natural sand. We had an understanding about the impacts of material usage in the construction industry. Now we'll understand the impacts in terms of energy conservation. The buildings also consume a large amount of energy, and when we consider about India's building energy use, the 33% of the nation's energy use is corresponding to buildings alone, and this demand is growing by 8% annually. This causes a huge requirement of energy consumption in buildings also. And when we speak about delivered energy consumption for residential and commercial buildings in India, this causes an increase by an average of 2.7% per year between 2015 and 2040, and also this demand is more than twice the global average. So summing up, we understand that the building construction or buildings usage demands a large amount of energy compared to the energy requirement of all other sectors, and this really needs an intervention measure. And EIA's International Energy Outlook also projects that among all the regions of the world, the fastest growth in buildings energy consumption will occur only in India, and India's residences demand more than 68% of electricity in 2040, which is nearly 4 times the average happened in 2015. So considering this also, we have a potential to grow the green buildings in such a way that the energy consumption should be minimized in India. Another broad sector is the water consumption in buildings. The United Nations Environment Programme indicates that over an entire life cycle, the building industry consumes a global average of 30% of fresh water and generates 30% of world's effluents. And huge quantities of water are consumed for manufacturing most of the building materials. This also adds to the water demand. Building construction industry is one sector which consumes a substantially high amount of water every year. The rate of extraction of water also far supersedes the rate of replenishment. For every square meter of wall construction, an average of 350 liters of water gets consumed. Overall, we have a huge consumption of water of more than 20% of the world's water demand only for building construction. And when we see about the trends in atmospheric carbon dioxide concentration, we are observing a graph here, and the graph or the curve peaks high during the very recent years. This data has been taken during 2020, and we can observe that almost the graph has reached a maximum of carbon dioxide concentration. So we understand that we have to take really very essential steps to reduce the global carbon footprint. And the manufacture of materials like steel, concrete, aluminum, and most of the building raw materials accounts for 11% of the global carbon dioxide emissions to the world. Thus, we totally understand that the building construction, owing to its requirement of raw materials and also due to its energy consumption, also due to its water consumption, overall it really affects the environment not only in terms of pollution, in terms of usage of raw materials, but also with its huge amount of carbon dioxide emissions. Thus, we understand that we should adopt a holistic and sustainable approach to buildings. Thus, the overall major domain of green building covers the most important areas like sustainable sites, water efficiency, energy management, materials and resources, indoor environment air quality, and some of the innovative ideas that could be incorporated to convert the built environment into an eco-friendly and sustainable built environment. This today's presentation is over. We will continue with exploring deep into the concepts of green building in the next presentation. Thank you.